Yeah. Yeah, good evening all. So myself, I'm Vijay. Like I hold nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment. So as part of today's demo, I'll be covering the following topics, right? What is big data? Why Hadoop and Spark? Drawbacks with the current databases, Hadoop and Spark advantages, and Hadoop components, right? And Hadoop and Spark job market. So before I go right, first have a look at what is the course content is discussed as part of this. So big data introduction, need for Hadoop, sources and types of data, comparison with other technologies, that is speed wise, processing wise, and storage wise, challenges with big data, databases in the Hadoop, advantages of Hadoop, Hadoop ecosystem components. So for we have got some drawbacks with the databases despite of drawbacks, right? Still we doesn't go with the databases. We go with a file system called Hadoop distributed file system, HDFS in brief. So what are the HDFS features? There are HDFS architecture, metadata management, storage and processing, replications. There is a duplications of the data and configuration, providing our custom replications, HDFS commands, right? One all that commands we're discussing. Map reduce, right? Map reduce architecture, job tracker, task tracker, and the splits and programming. Let map reduce processing and the scoop. It's one of the important component where like series SQL plus Hadoop. The first two characters of SQL, last three characters of this forms scoop, right? Scoop importing and exporting data from other data sources to Hadoop environment. After processing the data, again taking the data back to the data sources, different data. So yarn, yet another, the full form of yarn, yet another resource negotiator, right? Yeah. Means from Hadoop 2 version onwards, we have got many architectural changes, and what all the drawbacks we have seen in previous versions, everything have been rectified. And I'll be discussing one NoSQL database. HBase, right? HBase is one NoSQL database, HQS operations, and Hive. Hive is one of the important component, right? We use a language for data warehouse kind of environment. We go for Hive. We create tables. We make the data structure and create tables, different types of tables, internal, external tables, loading data from local, from HDFS files, working with unstructured, with XML, JSON, URL, weblog data, and UDFs, UDAF, UDTFs, right? And the major portion, right? What I say, like PySpark, Spark with Python implementation, right? So what is Spark? Why need of Spark? Real life usage of PySpark. PySpark computations or already computations, persistence features options, PySpark core computations, groupings and aggregations, various actions and transformations in brief, inbuilt functionalities, one by one in brief with many working examples. PySpark SQL data frame, right? PySpark SQL data frame, PySpark data frames, creating empty data frames, struct type, row type, struct field, show, row class, column class, select, collect with column renamed, where, filter, drop, order by group, join, union, or union by name, map, flat map for each sample by fill x, PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, PySpark built-in functions, right? When expr, lit, split, substring, translate, overlay, to timestamp, to date format, date diff. Yes. Array underscore contains array. Yes. Select underscore, right? Struct map values, map keys, row numbers, right? Rank, dense rank, percentage rank, JSON tuple, right? Yes. Many working examples, right? And PySpark external sources working with pure SQL statements, Spark and Hive integration, right? Yes. One second. Yes. Yeah, PySpark external sources. Yes. Working with CSV files, JSON files, actions, transformations, narrow and wide transformations, narrow transformations, wide transformations, adding new columns, dropping columns, renaming, window function, writing data to external sources, right? And deployment modes, local mode, cluster mode, PySpark applications, stages, task, drivers, executors, deploying Spark applications to cluster and tuning, performance tuning, PySpark streaming concepts, integrations with Kafka, and PySpark ML right? All this will be discussed. So in brief, in depth, we'll be discussing about all this PySpark and Hadoop components, right? Yes. Yeah. So for your general queries, I'll be giving, okay. So like, okay, previously, yes, Apache Pig is now, it's not preferred, right? So it got outdated. Apache Pig is totally outdated now because Apache Pig is a data flow language. Spark is also a data flow language. So Spark is mostly used now, right? As compared to Apache Pig. Yes. Yes. So, okay, components of my Hadoop and PySpark. So in brief, it will be discussed, right? It's coming to our right. What is big data? Why? Okay. So huge volumes of data is getting generated, right? KBs, MBs, GBs, terabytes, petabytes, exabytes, zettabytes, zettabytes, and sottabytes. From TB onwards, we say like huge data, right? From TB, terabytes, petabytes, exabytes. You should have seen KBs, MBs, or GBs, or even. So part of Hadoop administration also will be discussed, right? Yes. Installations, these things. More concentration on the development side. Okay. So here, have you seen 1 petabyte equal to 1024 TBs? Do you think examples of petabytes of data generations? So today, if you talk about the banking sector or telecom sector generating data in petabytes, or if you example of this Facebook, right? Facebook, right, has got millions and trillions of users throughout the world. In a minute, how many posts and videos are getting circulated? What is the storage generated by Facebook in a minute? It's not in MBs or in GBs, in petabytes of data. Not only like a Facebook, right? Today, if you talk about any application, just to take 1 minute transaction, to take just 1 minute transaction, right? Generating huge data, just 1 minute. If you talk about Facebook, in a minute, the data generated by Facebook. Twitter tweets keeps on generating. Twitter tweets keeps on generating, right? Google queries. Or if you talk about creating your own videos and uploading in the YouTube, right? YouTube videos upload. And your email messages, millions and trillions of people using these email messages. What should be the storage capacity to store all this, right? And apart from that, bank transactions, telecom transactions, or e-commerce e-commerce transactions, right? Like Flipkart, Amazon, all this, right? Everywhere we see like huge data. So currently we have got databases like Oracle, MySQL, DB2 SQL Server, right? It's a OLTP, online transactional processing. For day-to-day operations, we have got these databases. It can handle some GBs of data. But we have got some specialized databases like Teradata, Netezza, Vertica, right? They are used for analytical processing, for data warehouse process, right? So they can handle TBs of data, but to handle huge data, unlimited data, right? We doesn't have proper tools. So as a solution to all the storage level problems, right? We have got a framework called Hadoop, which is meant for both storage and processing, which is meant for both storing and processing. So here, if you see the biggest day by day data is increasing enormously. Data is the reasons for huge data generation, for huge data because of yes. Yeah, Python basics I'll be providing for this, not a problem. Right. So here for storage and processing, right? Yes. So data is generating enormously. If you talk about this data, right? Why this huge data is getting generated from the last 10 years as compared with the previous 40, 50 years, right? Especially from the last 10 years, huge data you can see. Whatever data you are seeing in the current world, nearly 80% of the data what we are seeing currently has been generated from the last 10 years. Previous 50 years, only 20% of data you can see, right? Because of usage of technology, usage of internet, because of usage of smartphones, right? Huge data is getting generated. And if you see that types of data, types of data like we see like structured data, like Excel files, database tables, right? And semi-structured data example, right? Like XML files, JSON files, right? And unstructured data like chart messages, articles, videos, images, links, right? So that now today the biggest challenge is how can we handle this unstructured data? Most of the data what it is getting generated in the current world is occupying unstructured format. So databases cannot handle this unstructured data, right? They can handle only structured data. So the biggest challenge is how can we handle this unstructured data, storing and processing it. So Hadoop can process all varieties of data, structured, unstructured, and semi-structured. Hadoop is meant for storage and processing. Any technology, if you take, either it is meant for storing or meant for processing. You take example like C, C++, Java, .NET, all are meant for processing. Like Oracle, MySQL, DB2, Teradata, and Netezza, they are meant for storage, either storing or processing. But Hadoop combines both storage and processing. That to unlimited storage is possible, and for processing, high speed processing. Yes. But for storing the data, does Hadoop use any database internally? Means no. Does Hadoop use, for storing Hadoop's data, does it use any database? No. Why? Because databases has got some drawbacks, right? Databases has got drawbacks. I'll be just briefing you about those. Despite of those drawbacks, still Hadoop doesn't go with databases. So can anyone please confirm, is my voice clear to all? Yes. Fine. So we are going with a special kind of file system called Hadoop distributed file system. Hadoop distributed file system, right? Yes. Processing. For processing, we go for MapReduce. Currently, we are going with Spark. So any technology meant for either storing or processing, but Hadoop is meant for both storing and processing. We can perform both, right? There are two unlimited storage and very high speed processing. You may get one query immediately, right? When Hadoop is meant for both storing and processing, then why again all these technologies like C, C++, Java, .NET for processing, and why this storage like Oracle, MySQL means you need to clearly understand. You need to clearly understand Hadoop is meant for what kind of applications. So for huge data and for big data, right? For huge data, right? And for kind of batch processing, Hadoop is good. For huge data, for small data, Hadoop is bad. For small data, right? For huge data, Hadoop is good. So Hadoop is meant for batch processing. Hadoop is not for online processing. For one record or two records, for one online transaction, Hadoop is not required. Go with database. But millions and trillions of records, right? Go for Hadoop. Hadoop is meant for batch processing, for batch applications. There are two types of applications. There are two types of applications: online applications and batch applications. Online and batch applications. Hadoop is meant for batch, not for online applications. Hadoop is meant for online applications. What do you mean by online applications? User interactive applications. User gives the input. Booking, for example, booking a movie ticket, making a online transaction. What? And what do you mean by batch application? Means user non-interactive application. User non-interactive applications. Here user is nowhere required for batch applications. Means what are the Hadoop or this Hadoop applications or Spark applications? User input is nowhere required. Most of the financial and commercial applications, they are batch applications, right? For example, railway ticketing PNR status. Railway ticketing PNR status, right? Your waiting status currently A200. After 2 hours, it is 150. Tomorrow morning, 100. Tomorrow afternoon, it is 50. Tomorrow evening, you got confirmed, right? Means here user input is nowhere required. Here, credit card statement generation. Credit card statement, right? For millions of customers. User doesn't give any input for it. Yes. So Hadoop is meant for batch, not for online applications. But even if you want Hadoop to perform online applications, Hadoop integration with NoSQL database. Hadoop integration with NoSQL database. Yes, 1 second. So understood, right? Hadoop is meant for storing and processing. For storing, a special kind of file system is followed, right? Hadoop distributed file system. And for processing, yes, I'll brief you about that Hadoop distributed file system. Yes. Why databases like Oracle is not used for storing Hadoop's data? Databases like Oracle is not used. Why databases like Oracles are not used for storing Hadoop's data? What is the drawback with the current databases? What are the drawbacks with the current databases means? Yes, as compared to Hadoop, I'm saying, as compared with Hadoop. See, drawbacks with the current databases. See, these are all the drawbacks, right? First one, limited storage. Most of the databases, limited storage, GBs or TBs. But unlimited storage not possible with the current databases. And most of the databases, no parallel processing. No parallel processing in most of the data. And one more thing, right? It's a weekend batch. On Saturdays and Sundays, it will be 2 to 2.5 hours on Saturday and 2.5 hours on Sunday. Total 5 hours, right? 2.5 hours on Saturday, 2.5 hours on Sunday. Totally 5 hours you will be getting per week, right? So today the session goes for 2 hours, right? Next. As volume increases, right? As volume increases, speed decreases, right? As volume increasing, speed decreases. The major drawback, right? See these queries, right? Sum of amount from sales one. Select sum of amount from sales one. It has got 10 records. Assume that it has got 10 records. So sum of amount from sales two. Let's think it has got 1 lakh records. Sum of amount from sales three. Think it has got 1 crore records. Sum of amount from sales one, 10 records. Sum of amount from sales two, 1 lakh records. Sum of amount from sales three, 1 crore records, right? Which query execute faster among these three? 10 records or 1 lakh records or 1 crore records? The total amount from, obviously the first query executes, right? Obviously the first query is going to execute faster as compared to the remaining queries. Means query to query volume increasing, speed decreasing. As the volume increasing, speed is decreasing. Complexity increases, speed decreases. Observe this: total amount from sales one, average amount from sales one, standard deviation of one amount from sales one. Observe this query to query. Which query executes faster from these three? Again, the first query, because average amount is a two-step process. First sum to be calculated, next average to be calculated. As compared with the first query, second query is going to take more time. And standard deviation, lot of internal processing is required. So query to query, as the complexity increasing, speed decreasing, right? And the major drawback with the databases, they can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. Hadoop won't follow client server architecture. Hadoop is not for client server architecture. Hadoop is for master slave architecture. Hadoop is not for request response. If you give a request, getting response. Hadoop follows master slave architecture. Single master, multiple slaves. Means we have got Hadoop cluster. Group of CPUs connected within a network. Group of CPUs connected in a network. CPUs means nodes, we say. CPUs means nodes. There are two types of nodes here. Master node, we call it as name node in Hadoop. Master node, name node. In Hadoop terminology, slave node as data node. Single master, multiple slaves. Master, these are slaves. Data nodes, slave nodes are data nodes. Why the name data nodes means data stored within the slaves and data processed by the slaves. Where data is stored within the slave nodes, slave systems, and data processed by the slave systems. When everything done by the slaves, what master is doing? Assigning the tasks. T1 task to system 1, T2 task to system, T3 task assignment. Balancing the load taken care by the master. Task assignment, master node responsibility. Load balancing, fault tolerance means when multiple systems are running parallelly, suddenly if any system fails as they are machines, right? Then the task of that system need to be assigned to any of the other system that we call like fault tolerance and health monitoring. Slave node responsibilities. What are the slave node responsibilities? Storing data and for processing data. See here, master node responsibilities, slave node, right? Yes. Stores data. Slave nodes only are going to store the data. Slave nodes are only going to process the data. If you observe in Hadoop, data is stored in the form of files. f1.txt. Think that the file size is 2 TB. Here each system capacity 1 TB, 1 TB, 1 TB. But 2 TB cannot fit into any of these systems, right? Then this 2 TB in Hadoop, any file if we take, it will be splitted into smaller parts. It will be splitted into smaller parts automatically. And each one is given to one system. Each one given to one system and is processed parallelly and is going to be processed parallelly. So f1.txt 2 TB divided into smaller parts, that each part is going to be stored across multiple systems. Okay. Hadoop advantages, drawbacks with the databases. We have seen that major drawback with the databases, they cannot handle structured data. Huge data storage not possible. No, most of the databases, no parallel processing. If volume increases, speed decreasing, right? But Hadoop advantages. Unlimited storage, unlimited data storage is possible. Unlimited data storage is possible in Hadoop because of a feature horizontally unlimited scalability. So there is one feature in Hadoop, horizontally unlimited scalability. Means, for example, today you got a business with very less number of slaves, master and slaves. So these are the slaves systems. You're running a business with just 10 systems. Your business has increased. Your branches has increased. Your data has increased. Your customers have increased. You cannot go with the same number of systems, right? Just horizontally, you keep on increasing the systems. Horizontally, you can keep on increasing the system. Slaves. Horizontally unlimited scalability. Horizontally, unlimited number of slaves can be added. Yes, the first advantage is horizontally unlimited scalability. Yes, if data increased, okay. If customers increased by 100 times, data increased by 1,000 times, then you won't go with the same number of slaves. You will increase the number of systems. Yes. One more advantage is very high speed processing, right? Because of the parallel processing. Because of what? Parallel processing. Can handle all varieties of data. Hadoop can handle all varieties of data, structured, unstructured, semi-structured, right? So it is an open source, no licensing required. So most of the Hadoop products are from Apache, right? Apache products. That commodity hardware means not like highly configured hardware. It's not required. Can run on any hardware. Okay. So these are the major advantages, right? Unlimited storage, very high speed processing, can handle all varieties of data, and open source, no licensing rate, commodity hardware. So these are the major advantages, right? And you may get query like why databases like Oracle won't support unlimited storage? Why databases like Oracle won't support unlimited storage? Even like databases like Oracle, MySQL, DB2, Teradata, Netezza, what all the databases. Even you can go with multiple slaves, multiple systems, but there is a limit on them. Observe here. So yes. Databases and max limit on the number of slaves, max limit on the number of slaves. Oracle max it can go with 256 systems or nodes, right? MySQL can go with only 54. MySQL Express, right? It can go with 256 nodes. DB2 also with 256 nodes. SQL Server with can go with 256. Teradata max like 512 nodes. Netezza also 512. But currently, Teradata and Netezza are supporting 1024 nodes of CPUs, right? But if you talk about these databases or the specialized databases, max they can go up to 1000 systems. But beyond that, if they cannot support data further. But there is no limit on the number of systems that Hadoop can have. Nodes that system. Excuse me. Hadoop. There is no limit on the number of nodes that Hadoop can have. Horizontally unlimited scalability. Horizontally unlimited scalability. See, Yahoo, when first time implemented Hadoop, it went with 4,000 systems. Currently, Yahoo going with 12,000 slaves in the means nodes. Facebook, when first time implemented Hadoop, went with 8,000 slaves node systems, right? Currently, Facebook going with 42,000 nodes. Yeah. So Hadoop is proven in the market, storage point of view with unlimited data storage is available. Yes. So Hadoop is proven in the storage point of view, not only storage point of view, right? Processing point of view also. very high speed processing, right? You can see like Yahoo has conducted a test to check the speed of different databases, right? Yes. Yahoo has taken a table of 100 TB, has taken a table of 100 TB with 1024 columns. The task is sorting based on 16 columns. Observe here, to check the speed of different databases, right? It has taken a table of 100 TB, 1024 columns. Task sorting based on 16 columns. What is the time taken? What is the time taken by Oracle? It has taken 3.5 days to process. MySQL has taken 6 days. Teradata has taken 4.5 hours because it can handle TBs of data. Netija has taken 3 hours time, right? And Hadoop has just taken 4.3 minutes. Just Hadoop, see this has taken days of time. This have taken hours of time. But Hadoop just minutes. Latest version of Hadoop has just taken 2.4 minutes. 2.4 minutes, right? Yeah, that is what the speed of, that is the what speed of Hadoop, right? As compared with other things. So Hadoop has proven in the market, storage point of view and a processing point of view, right? So Hadoop ecosystem components that I'm going to discuss, right? For Hadoop ecosystem components for storing and processing, HDFS for storage, MapReduce for processing, Hive also for data warehouse kind of environment. We use a language called HQL, which is similar to SQL, right? And Scoop, SQL plus Hadoop for import or export, NoSQL, HBase. Yeah, just now I showed you that course content, right? The same thing. Yarn, Zookeeper, controls and coordinates, all the other Hadoop components. Fluent Kafka. I'm going to give the knowledge on this Fluent Kafka, right? Streaming data, streaming technologies, and PySpark, core programming, PySpark SQL, PySpark streaming, NML LibRent, machine learning lab. Okay. This is regarding Hadoop, right? Just I'll give some introduction to this PySpark also, right? Very high speed processing, right? I'll give some. Okay. PySpark. What is Apache Spark and why PySpark? Need for PySpark. PySpark features, real-time usage of PySpark and its job market. See, Apache Spark, it is an open source, distributed and in-memory processing technology, right? Framework introduced by Apache software for Apache, right? Apache Foundation. It is a general engine, right? Spark is a general engine for big data analysis, for processing and computation. Why PySpark? Why PySpark means I can say it's a Python API. Why PySpark means it's a Python API, right? To use a Spark. So PySpark is the lightning fast technology that is designed for fast computation. PySpark is a very demanding tool among the data engineers to work with bigger data sets. Today, if you see, it has got a great boom in today's market. PySpark is used for what? For running distributed SQL, for creating data pipelines, for ingesting data, for running ML algorithms. Yes. for data pipelines, for ingesting data, and for running ML algorithms, and for graphs or data streams. Need for PySpark. What is the need for PySpark means? See, a large amount of data is getting generated through offline and online, right? This data contains hidden patterns, unknown corrections, market trends, customer preferences, right? And some other useful business information. It is necessary to extract that valuable information from the raw data. So we require more efficient tools to perform these operations, right? So there are you may think there are already many tools available to perform multiple tasks on huge data sets, but those tools are not that much of appealing, right? So it is required some scalable and flexible tools to crack this big data and gain benefit from it. Yes. So PySpark. So here we need to have a scalable and flexible for cracking this big data and gain benefit. So PySpark is such a kind, I say. So combining Python and Spark is a very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark. That is Python API for using Spark. Python API for using Spark. Yes. So real life usage of PySpark means yes. In commercial sector, it is used means for Spark real-time processing, banks and other commercial and financial fields using Spark to retrieve the customer's social media information and to gain useful insights from that. Yes. Credit risk assessment, targeted ads, and the customer segmentations. Yes. In healthcare also, right? Spark to analyze patient's record along with their previous medical reports, which patient is able to face that issues even being after discharge from the clinic. And entertainment industry, and it is the largest sector which grows towards online streaming. The popular online streaming, right? The popular online streaming like Netflix uses Apache Spark real-time processing, right? Yes. This online movies, web series, etc. all right today, like which is using Apache Spark, which process nearly 450 billion events per day that are streamed over server-side applications, right? So they even in trade and e-commerce, Flipkart, Amazon, all this they're using Apache Spark, right? For advertising, right? And for enhanced customer experience. And tourism industry also, right? Using this Apache Spark. Okay. So that is what a small introduction to this PySpark and Hadoop, right? What is PySpark and what is Hadoop? Why we go for Hadoop and PySpark, right? If you have got any general queries, you can ask me up. We'll have a small break before we go with. So it's weekend batch, right? It's not like regular batch 1 hour. Weekend batch, we need to go with 2.5 hours, right? Yes. So any queries you got before we have a break? Anyone, you have any queries? Any queries, right? Anyone have got any queries?
Hi.
Yes.
I have one question for this PySpark, will there be any or for this full course, will there be any real-time project discussion implementation of whatever other learning we have?
Yes,
What?
yes. Yes, definitely. The last one project flow I'll be discussing.
so that we can, whatever the learning we learn, we can implement or we can correlate in our like
Yes,
in
yes,
views.
yes, yes, yes.
And
Many
also
wo-
like I'm from basically a little bit know the Python syntax. So I think will that not create too much problem because I'm right now learning Python basics. So like will
so
that be covered or for
so 1 second, you are said you are learning Python, right?
Mhm,
So for the next 1 month, first we'll be starting with Hadoop, right? For
mhm.
Hadoop, that is nothing Python. When we go for Spark after 1 month, then we're using Spark with Python, PySpark, right? Then required for the first 1 month, first 4 5 weeks, right? We won't touch anything related to Python.
Okay, and like for the labs and the practical session practice, those things which
Yes,
are,
yes.
is there any environment or lab environment to be provided? Like
Yes, yes, yes. Queries was one more query also asked whether also how will the labs for practicals be administered? Will there be any cluster created for us to? Yes, I will be creating, right? I have
Mhm.
already created. I'll be forwarding you to your Google Drive, right? You will be downloading from there, and I'll be just demonstrating how to work, how to download, and how to install them, how to work
Okay,
with this, right? VM
so
image I'll be
okay,
providing.
it will be like just like means dummy kind of environment where we will be working all together, like what were the practical scenarios or use
Yeah, all
cases.
yeah, to work for you people to work on your laptops, right? I'll be providing that image, VM image, right? Where you can see all the Hadoop components and Spark components will be installed, and I'll be providing you whichever component you can just start it and use it. And you can check that example course, right? That's
And for PySpark, like Databricks integration, like where we will be practicing those PySpark
yeah, yeah.
parts.
That also on Databricks. I'll say I'll just also give knowledge on that.
Okay, means for that subscription is required, right?
So no, no, no.
Database community edition.
So just I'll say how to work on it, right? Freely also.
Okay, okay. Means one last question. Like there
Yes.
will be no point of there will be no point where we will be like restricted just because of we are not able to practice. Means all those
No,
practical
no,
sessions.
everything, what all we are learning in this part of the course, you will be doing practically, right?
Okay.
You will be doing practically, yes. I'll be
Okay.
showing you, I'll be giving that VM image where you can see all the Hadoop and Spark components. And I'll also show you that if a Jupyter notebook, how to run all this course in the Jupyter notebook, and also like Databricks, right? I'll
Mhm.
show you all these different environments, right? And a cloud data distribution also, right? In built, you will be getting these things. Okay, fine. No, don't worry about this softwares and this how we can practice. It will be, I'll be forwarding those things, right? I'll be demonstrating. You will be just downloading and you will be installing on your systems.
Okay. Thanks.
Yes. So just I was briefing you about Hadoop and Spark, right? Both today like PySpark has got great boom. Can see like even the salary packages as compared with other technologies, right? For this PySpark data engineering, right? 1.5 times more than other technologies you can compare, right? Because at the same time, they will be expecting the command in the technology, right? So everything from step by step, line by line, everything I'll be showing you. I'll be explaining you, right? Yes, it is like interactive sessions. You'll be interacting with me, right? You will be kept in unmuted status. You can ask any query at any point of time during the session. So clear notes I'll be providing. You'll be getting the recorded videos also, right? Every session is video recorded. You will be getting the recorded video. Even if you are absent, can go through that. You will get 1 week of time, right? It's a weekend batch. Then go through the videos and attend the next session if any queries. And also a WhatsApp group will be created for your technical discussions, right? Yes.
What would be the timing for this batch?
Yes. So I'll make it clear about these timings, right? Yes. Okay. 5:30 to 6 to 8. 6 to 8 after, so I'll be going with 8:20 or 8:30, right? So it will be like 6 o'clock, 6 to 8, 6 to 8 or 8:30 on Saturday and Sunday.
This is in the evening.
In the evening, same time, right? Evening, right? 6 o'clock on Saturday and Sunday.
Okay, what about if someone doesn't know the Python, then do we need to learn Python before we go for PySpark?
So, okay, I'll be just briefing you about the syntaxes of Python before I go with Spark, right? So I'll take some sessions on that. And even if you've got time, see, we have got 1 month of time before we go with Spark. I'll be discussing Hadoop first. So if you're able to update, okay, I also take Python batches also, separate Python batches, Python core and advanced, right? So for Monday at 9 p.m. a regular batch is going to start. Monday 9 p.m. in the evening. From Monday, it's a daily base. If anyone interested, you can just go with that.
So will that be any extra special fee, extra fees will be included
What is
for
it?
this Python system?
Python, what is it?
And there's extra fees or pricing for this course, Python.
So Python, actually the course fees is for this Python is 5,000, right? So people who are attending this big data, people who are attending this big data, right? They'll be given some discount for it. You can just talk with the online team, right? For it.
Okay, sure.
And in that Python course, so you are going to cover only the things that are required for data engineering, right? Not all the, like for Django
No,
or
no, no.
and then
Python core and advanced, everything will be discussed. Not like the Django, it will be excluding, right? Yes. Yes. Now,
and one more question, like are you going to cover any cloud like this PySpark with any cloud tech platform like Azure or AWS?
yes, yes, one second. Yeah, at the last, I'll be showing you on that cloud environment also, right? How we can perform all these things. Yes. So, yes, now, how exactly data stored, how exactly data is stored in Hadoop, right? Yes. How exactly data storage is happening within the Hadoop. In Hadoop, data is stored in the form of files. In databases, it is stored in the form of tables, right? But here it is stored in the form of files. Each file is subdivided into smaller parts called blocks. Because if you've got a very big file, the very big file cannot fit into a particular system or slave, right? So it will be divided into smaller parts. We call like blocks. Each block size, default size is 128 MB. What is the default 128 MB? In older version, it was 64 MB, right? It was 64 MB. Okay, for example, yes, see these diagrams, right? Yes. If I take a file f1.txt, assume if the file size is 192 MB. If the file size is 192 MB, default block size, assume the block size, default the block size is 6. We can keep our own block size also depending, right? Assume the block size is 64 MB. Yeah. So for example, I'm taking whatever the file is divided into fixed size blocks. By default 64 MB or 128 MB, right? Default, whatever we can configure custom block size. 192 by 64. Think that 3 blocks. You get like 3 blocks, B1, B2, and B3. B1, B2, and B3. B1 block, B2 block, and B3 block. How these blocks are getting distributed means, so this is the master, these are the slaves. Master and slaves. S1, S2, and S3. This is the master node. Master node, right? Within this, we have got a service like name node, we say. It maintains metadata information. It maintains metadata. Means f1.txt file divided into how many blocks? B1, B2, and B3 blocks, where B1 stored here, B2 stored here, and B3 stored here, right? Yes. B1 stored in slave 1, B2 in slave 2, B3 in slave 3. Okay, means any file of whatever size it is, it will be splitted into blocks. If very big file, multiple 30 blocks, 20 blocks. How they are distributed across the slaves? Yes. And processing this, right? How this is getting processed? Job to process this f1.txt. They are processing this f1.txt. Always the job divided into tasks. Into how many tasks? They are divided into tasks. Number of tasks always depends on number of unique blocks. How many unique blocks? 3 blocks, right? 3 blocks. Number of tasks, job divided into tasks, the number of unique blocks, 3 tasks here. What are the 3 tasks? T1 task to execute B1, T2 task to execute B2, T3 task to execute B3. See, B1 has got, assume, some 10 lakh records. It has got some 10 lakh, it has got some 10 lakh. Means executing this 10 lakh records, T1, this T2 task, and this T3 task, means data is distributed across multiple systems and processed by multiple systems parallelly, right? So that's why we see 2 advantages. Any file you split and distribute and store, right? And process it parallelly. So here, your job to process f1.txt divided into multiple tasks. T1 task, T2 task, T3 task. T1 task is for executing B1 block. T2 is for executing B2. T3 is executing B3. Yes. All 3 tasks T1, T2, T3 are executed parallelly by 3 slaves, S1, S2, S3, right? Yes. So full parallel processing, high speed you are going to see. But if the number of blocks are more and the systems are less, assume that you have got 10 blocks, only 5 systems, 5 slaves are available. 5 slaves, 10 blocks and 5 slaves are available means S1, S2, S3, S4, S5. 5 systems are the 5 slaves. S1 is storing, right? 2 blocks. This also 2 blocks. It also stores 2 blocks, 2 blocks, 2 blocks. B1, B2, B3, B4, B5, B6, B7, B8, B9, B10 means each system storing and B1 task, T1 task. For executing B2, T2, this one T3, T4, T5, T6, T7, T8, T9, T10 means these 5 systems can execute only 5 tasks. 5 tasks parallelly. Remaining 5 tasks will be in the waiting state. 5 tasks are in the waiting state. Means here we won't see full parallel processing. Slaves are less, blocks are more. Slaves are less, blocks are more, right? Means only 5 tasks will be executed. Slave 1 execute B1 block, that is T1 task. T2 will be waiting. Here in slave 2, this will be executing, this will be waiting. This will be executing, this will be waiting. See, 5 tasks are executed parallelly. Once their task got completed, next the tasks which are in the waiting means number of blocks matches with the number of systems or slaves. Full parallel processing, very high speed. If these blocks are more than the slaves, less speed you see. This one, more speed you see. If multiple blocks but only one slave, that slave only has to execute all the blocks, 10 blocks, S1, S2, B1, B2, all these blocks, 10 blocks, sequentially one after the other, right? It's time-taking process. When 3 tasks are executed parallelly by 3 slaves, S1, S2, and S3, suddenly if this system S2 goes down, assume as they are machines, right? Then the task, two things you need to have, this data, that is 10 lakh records are lost, and this T2 task will be failed. In such case, right, Hadoop is coming with a concept called replication and fault tolerance. Replication and fault tolerance. Replication, nothing but duplication. For example, f1.txt, you got a file, the size is 192 MB. Into how many blocks? Number of blocks, assume 192 by, so whatever the divided into blocks, 64 MB blocks, 3 blocks. Means it is divided, this file is divided into 3 parts. You got 3 blocks, B1, B2, and B3. In Hadoop, default replications 3. Default number of replications 3. Even if you want more or less, you can configure it. B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times. And how they are getting stored across the cluster. How they are going to distribute across the cluster. This is master node. We say like name node, stores metadata. So here how these 9 blocks, B1 by 3 times, B2 by 3 times, B3 by 3 times. Totally 9 blocks. B1 here, B2 here, B3 here. B1, B2, and B3. Again, 9 blocks, right? B2, B3, B2, B1, B3, B3, B1, B2. 9 blocks distributed across 3 systems, S1, S2, and S3. So here your file f1.txt file divided into 3 blocks, B1, B2, and B3, where B1 stored in S1, S2, and S3. B2 in S1, S2, and S3. B3 also stored in S1, S2, and S3. So here assume T1 task, T2 task, T3 task. 3 tasks assigned to 3 slaves. T1 task to S1, T2 task to S2, T3 task to S3. T1 should execute B1 block, T2 should execute B2 block, T3 should execute B3 block. 3 blocks executed by 3. If 3 tasks are executed parallelly by these 3 slaves, S1, S2, S3, right? Suddenly, if any one system goes down, do you think there is any data loss here? Try to understand. Still, the data available in S1, S3, right? Previously, there was a data loss in previous example, if there is no duplications or replications. So whenever you see any sensitive data, you need to replicate, or if it is data is insensitive, no need to any replications, right? So still data available in S1 and S3.
When you say the block like 64 MB block, does it mean like suppose a file is having like 5 million records and that file is divided into three parts into 3 blocks like 64 MB one, 64
So
MB
if you
two.
got a file size, here it's MB file, but if it is a GB file, you may think,
Yeah, I mean, yeah, in 192 MB. So we divided that file into 3 blocks. So my question is like what exactly does it mean like by block? When you say block, so it like suppose like we have a 6 million record in a file, then each block will have a 2 million record. Like we divide it into three.
No. 1 second. Okay. From Hadoop 2 version onwards, the block size means each file dividing into parts. A file f1.txt dividing into parts. Why it is divided into parts means when you divide into parts only, you get advantage. What advantage you get by dividing a file into parts? Each part we call as one block. Each part we call it as like block. Previously in the old versions, it was 64 MB default, each block size was. In this way, 64. In this 64. In this way, 64. It's continuous. 64, 64, 64, 64. But in the latest version, it has 128 MB. 128 MB. In this way, if the file size is bigger, it keeps on 128 MB blocks will be created. Parts. Divided into smaller parts. 128 MB, 128 MB, 128 MB, 128 MB. If the file
So
is
inside the file record will also be divided like suppose first
yes,
2 million record will be in the first
yes.
block.
Here the size is 192 MB means 3 blocks. But
Okay.
if the file size is 900 MB, 900 MB means nearly how many blocks you will get? 900 MB means nearly like about 20 blocks you get. Assume approximately like 20 or 20 blocks means 900 MB file f2.txt divided 900 MB divided into many parts. How many parts? 20 parts. Each part each part of some particular size, 128 MB in the latest configuration, 128 MB. 120 Indians, how many 128 MBs you will get for this? Nearly some 7. Okay, if it is 128 MB, nearly 7 partitions or 7 blocks you get.
How does it store the data in that block? Is like order wise in sequence, like first 2 million record will be in that block.
See, we no need to do all those things, right? Automatically it is taken care by it.
Yeah.
But framework takes care of it, this framework, right? And whenever if you want to retrieve it, right? Whenever you want to retrieve it, already it will have the entire information, which block stored in which slave, that information. If you want to retrieve, it will combine all the blocks and it retrieves the data for you from the multiple systems. So this splitting process and this combining process, retrieving process, taken care by framework. We as a developer don't need to do anything, right? So just we need to give this. You want each part of 64 MB you want, or these are the fixed size. Not only this, you can also give like 200 MB or 50 MB or 100 MB also. There will be a configuration file. In that file, you need to specify, I want each partition, each block size of so and so. This was in the older versions. In the new versions, it is 128. But even if not only this, you can have your own sizes. Means the file, each partition means that we call like block, right? What should be the size of it? We should not keep a bigger one. If you think like I will keep 500 MB as my block size, it has got some drawback. If your file size is 1 GB, you will get only 2 blocks, B1, B2, B1 block of 500, B2 block of 500. This is stored in one system. Means only 2 systems are storing, only 2 systems are running parallelly, less speed you get. But if it is 64 MB, you should have got in 10 systems will be running parallelly, more speed you will get, right? So that's why. So it should not be too bigger or too smaller. If it is too small, like 5 MB, it will be divided. A small file, if you take like 25 MB file, it is, if your block size is 5 MB, 5 MB, 5 MB, 5 MB, 5 MB, right? For a small file, again, you are dividing into smaller parts, distributed across multiple systems and processing, again, retrieving. It's time taking, right? So instead of that, the block size should not be too small or it should not be too large. That's why it is giving 128 MB. Means file is divided into multiple partitions. If your file is divided into multiple partitions only, then you can get multiple tasks. If you get multiple tasks only, then you can assign the task to multiple systems. But if it's only one, then only to one system you will be allocating, right? So the advantage, splitting, distributing, and parallelly processing. Here, observe. One more thing, that this is my master, slaves, master and slave. S1, S2, S3. T1 task, T2 task, T3 task. Here B1, B2, B3 present. B1, B2, B3 is present. B1, B2, and B3 is present. So this T1 task is for executing B1 block. T2 task for executing B2. T3 task is for executing B3. But suddenly if the system is down, then T2 is to execute B2, right? Then either T1 or T3 has to execute that B2. Means what is the criteria followed in assigning the task? in assigning the task to other slaves. What is the criteria to if this system S2 is failed? So what is the internal criteria followed, right? What is to T1? This is to S1 or to S3? To S1 or to S3 means first there is 4 steps criteria here. First thing is to S1 or S3 to which is assigned means among S1 and S3 which is very highly configured. Highly configured means which has got a good high configuration, hardware configuration. If S1 has got good hardware configuration, then to S1 it will be assigned to S3. But if they have got both equally configured, then it will check S1 or S3 which is more free, or which is ideal. If this S1 is free but S3 is assigning some 2 tasks, then it will be assigned to S1 which is more free. But think both are free, both are not executing anything. Then the one which is nearest to this, the one which is nearest to the master. So masters can be in one state, slaves can be in different states. Master can be in one country, slaves can be in different country. So all master and slaves can be within the same place in one lab. So the one which is nearest, think that S1 and S3 are equally near, assume. In such case, it will take the health status. Health status means even though this S1 and S3, right? Even though the S1 or S3 has got highly configured, doesn't mean that both have got good health status. Among these two, which one has got good health status? Health status in the sense, now and then this S1, there has got some hardware problem, or S1 has got some software problem. S2, S3 is totally good, has got good health. Then to this you assign it. So these are the 4 steps criteria. The one which is highly configured, the one which is more free, the one which is nearest, the one has got good health status. So so clearly I mentioned in this notes, right, what I discussed. 4 steps criteria. Master node selects the slave which is highly configured. If both are highly configured, then master node selects the slave which is more free. If both are free, then master node selects the one which is nearest to it. If the slaves are equally near, again master node selects the slave which has. But if think that both have got good health status, then master node selects any one slave randomly. So what do you mean by fault tolerance? Means when multiple tasks are executed by multiple systems, suddenly if any one slave goes down, then the task of it will be allocated to other slave. This process we call it as fault tolerance. Okay, you might be getting one more query here, right? See, don't think all this everything taken care by the framework itself. We are not going to do anything here. So just we are going to configure the things as per the requirements. So here, this is the master, these are the slaves. Okay. S1, S2, S3. If S2 is failed, the same task of it will be assigned to S1 or S3. But if the master node itself is down, the master is down. So this we call it like name node, I said. In the absence of the principal, we have vice principal, right? This absence of this name node, we got a secondary name node. Secondary name node. So if name node, if one slave is down means other slaves will be executing the task. But if the master itself is down means immediately secondary name node comes into picture. Principal is the highly authority, has got high authority, right, for in performing anything. But in the absence of the principal, vice principal doesn't have the full authority. Here also the same thing. Name node, secondary name node. Secondary name node is not 100% backup node. It is not 100% backup node. Name node can read, write, and update, but secondary name node can only read, cannot write or update. Okay, so understood the 4 steps criteria in allocating the task to the slaves. And here, if name node is down, secondary name node comes into picture. Secondary name node is not 100% backup, but during the absence of this name node, immediately secondary name node runs. Right. So to make it much more clear, right? Hadoop follows master slave architecture. Within the master, and these are slaves. This is master node, we say. This is slave node 1, slave node 2, slave node 3. Within the master node, within the system, right, 2 services will be running. One is name node service will be running. It's a service, system service. One is job tracker. So for storage, we have got name node, name node, data node, and secondary name node. Name node will be residing within the master node. Data node here. Data node 2. Observe, these are the services. Name node is one service running within the master node. Data node is service running within the slave. Data node 3. How many slaves? Those many data nodes. Secondary name node means if the name node is down, secondary name node comes into picture. Okay. This is storage, and for in Hadoop, processing related, right? We have got job tracker, task tracker. Job track, see this name node at master. Job tracker also at master. Who are at the master? Who is the master? Who is the master for storage means name node. It is responsible for all the storage level things. Who is responsible for all the processing related means job tracker. Okay, try to understand. In Hadoop, meant for storage and for processing. For storage, we have got 3 components: name node, data node, secondary name node. Name node will reside within the master. Data node will reside within the slave node. In each slave, one data node. Secondary name node, whenever name node is down only, secondary name node will be running. See, when name node is down only, secondary name node comes into picture, right? Secondary name node is comes into picture, right? How secondary name node comes to know that name node is down? How secondary name node comes to know that name node is down? Means there will be some heartbeat signals between those two. Heartbeats, if the heartbeat signal is missing, then secondary name node knows that name node is down. Immediately secondary name node will become active. And one more, here master node and this slave nodes, this T1 task, this T2 task, T3 task. If 3 tasks are executed parallelly, how come this master node comes to know that particular slave is down? For that also, there will be heartbeat signals between the master and the slave. Heartbeat signals are available. If that heartbeat signal is missing, then immediately this master node thinks that particular slave is down, immediately assign this task to other slave. Okay. So name node, where it will be? Within the master. Data node will be resides within the slaves. Secondary name node in the absence of the master, in the absence of the name node. And job tracker will reside within the master. And here task tracker, here task tracker 1, task tracker 2, task tracker 3. Who assigns the job? Job tracker. Who executes the task? Task tracker. So anything related to job related things, right? Anything related to job related, this job tracker and task tracker takes care. Job tracker assigns and task tracker executes. Anything related to storage, name node stores the metadata and data is stored by the data node. Right? So job tracker assigns the tasks to task trackers. Task trackers are responsible in executing the tasks. Task trackers are responsible in executing the task. So once the task is completed, a particular task tracker will give acknowledgement to this acknowledgement. Understand this? Who is the master for storage means name node. Who is the master for processing means job tracker. So this job tracker, if any file coming back to this master node, name node, it divides the file into blocks. Okay. Who is the master for storage? Name node. Who is the master for processing? Job tracker. So we have got storage, and Hadoop is meant for storing and processing. For storing, the master is name node. For storing, processing, the master is job tracker. Who divides a file into blocks? Name node will divide a file into blocks, and name node stores that blocks across the multiple systems, multiple data nodes. Who divides a job into tasks? Job tracker, which is within the master. Job tracker, which is within the master, is going to divide the job into tasks and distributes across multiple task trackers. Who stores the metadata means the name node only, which is within the master node. Who stores the actual data means data node. Who stores the actual data means data node. Who is responsible for executing the task? Task tracker. Who takes care of fault tolerance means if any one system is down and that task should be assigned to any other, right? Taken care by job tracker only. Anything related to processing, job tracker. Anything related to storage, this name. Who assigns the task? Job tracker. Who executes the task? Is this clear for you? The storage and processing point of view in this Hadoop framework and these components just I have given. In the master node, two things, name node and job tracker. Name node is for storage, job tracker is for processing. They act as the leaders, masters. In the slave node, what are the two? Now try to answer. In the slave node, what are the two components? Two services. Two components or two services within this. I want the interaction, right? The sessions to be more interactive. Yes, you can unmute yourself and you can give your responses, or you can type in the chat panel. In the slave node, data node and task tracker. Data in the slave node, data node and task tracker. In the master node, name node and job tracker. Who assigns the task? Job tracker. Who executes the task? Task tracker. Who stores the data? Data node. Who takes care in the absence of name node? Secondary name node.
This theoretically, like, we will be able to see this on the server, or how it is like, or any tool we will be able to see all these task tracker and name node.
So, okay, see this name node, data node. Okay, see services. Yes, 1 second. 1 second, I'll show you all those. So this in the practical, you will understand all those much better. I'll be showing. You. So, whenever you want to perform any storage related things, we need to start the storage services. What are the storage services? Name node, data node, secondary name node. Whenever you want to work with processing components, you need to start the processing components. Now, try to say once again, what are the storage things? For storage, name node, data node, secondary name node, these three. So in the practical we say, so if you want to start this services, right, the command start - distributed file system .sh, this command will start these three. Similarly, for processing, job tracker, but this job tracker name is changed, right, in the latest version. we say as resource manager. Task tracker name as node manager. So the job tracker and task tracker names in the latest versions changed to resource manager. And if you want to start this processing, we have got a command like start-yarn.sh. So these things you need to understand clearly before we go with the practical part. So this thing I'll be forwarding you, right? So here this Hadoop password is Hadoop. So this there will be icon. I'll start one terminal, right? So all this practically I'll be explaining you later in brief. First, try to understand the terminologies. View, zoom in, right? Yes. Now you can see. So for all this, right? JPS, what are the processes, right? What are the processes that are running? Nothing, they are running as of now, right? So start hyphen distributed dfs.sh. Now I'm starting the storage components, name node, data node, secondary name node. Check it. Name node will slowly, it will start name node, starting name node. Yes, starting name node, it will say. So this command is enough. Starting data node. Yes. And starting secondary name node.
This shell script will be available in the server, like in the live environment.
So whenever we install Hadoop, right, everything you get inbuilt, all these things. We don't need to. Whenever this Hadoop is installed, you can get all these things inbuilt.
Okay, so this shell script is used to start the all three nodes. Like
Yes. This command, right? This script is used to start all the storage components. Name node, data node, secondary name node.
Should we install this VMware workstation?
Yeah. I'll just explain all those things, right? Just I'm showing how to start it. So later I'll take separate session how to do that installations, everything. Like step by step, I'll show you how to download, how to install this. Don't worry about the software, right? So just I'm saying someone asked a query, right? How can we start? We will be able to see or not. Now I started name node, starting data node, starting secondary name node. Just if we say JPS, right? We'll say what are the things started. Previously nothing was started. Now you can see data node running at so and so process with so process ID, name node, data node, secondary name node. Now job tracker and task tracker. Right? Yes, they are the, but the names changed to resource manager and node manager. Same way, for that also to start the processing related, start hyphen yarn.sh. So I'll be discussing, we have got a lot of discussion on yarn, yet another resource negotiator, right? Yarn architecture, yarn components I'll be discussing, right? So if I start this processing components, job tracker means resource manager, task tracker means node manager. You can see this starting resource manager. Now starting node manager and starting resource and node manager. Now these three components and these two components, 5 components should be available running, right? I say always to perform storage and processing. 1, 2, 3 for storage. First 3 for storage, last 2 for processing. So clearly we need to start these things before you want to perform any storage or processing. These services should be running. And if you want to stop this, right, stop -yarn.sh. And for this also, right, stop -dfs.sh for stopping this thing. Starting and stopping.
Okay, so this part, like in the real project like we work, so this part will be taken care by admin, right?
So admin, everything they are taken care of admin, but we are going to look about the development things, right?
Right,
So
yeah.
our total course deals with this development processing related, and we should and so don't think like it will be very complex. People like big data, these things will be very complex, right? It looks very simple and easier, right? So we have got commands available, and if you go for technologies like Hive, it's a kind of data warehouse kind of environment. We use HQL language, which is almost 96% similar to SQL. Okay, this Hive means we are going to create tables here in Hive. We are going to create tables. We have got internal tables, external tables. Means internal tables means temporary tables, external tables means for regular usage, right? Means how you are making the data structured and storing into the tables. And after once you create table, you can perform HQL, means querying, just like SQL only we can perform querying of this, right? We can perform querying of data. And generally, huge data storage is possible in Hadoop. Huge data storage is possible in Hadoop. Hadoop is meant for storage and processing. This is storage, processing. Huge data. For storage, HDFS. And for processing, right? Okay, we have got many processing components. See, in HDFS, there won't be any data initially. See, if you have got some branches, different data sources, different branches, database 1, database 2, database 3. So data source, OLTPs. From different OLTPs or from different data sources, right? If you have got a branch, this is Hyderabad, this is Mumbai, this is Chennai. So you are pulling data, you are taking put data into HDFS. You are taking data into HDFS. How you pull the data, how you are pulling the data from different databases? There is a component I said, scoop. Using this SQL plus Hadoop, scoop. Using scoop, it is very just like a command is the commands are there. Using that, you can just bring the data into HDFS. After that, from HDFS, you take that data, whatever data you got, right? It has to be processed. Mostly you can go for Hive processing, or you can go with Spark processing, right? Spark is very high speed in memory computation, right? So Hive, the main advantage of Hive, it can integrate with any other data sources and any other sources. After processing, again, if you want to export it, again using scoop only, you will export it. Again, using scoop only, you are going to export it to database. So here you are pulling the data into one place, means HDFS is the place where it can accommodate huge data. Even some 50 branches, you bring the data, yes, it will accommodate it. Stores across multiple systems. Using scope, you will export it. How you can integrate with any other things like NoSQLs. Fine. So so once again, summarizing, right? Yes, this is the master. These are the slaves. Yes. This is system slave 1. This is slave 2. This is slave 3. And this is the master node. Try to say everyone, right? I want interactions from you. What are stored in the master node system? What
Name
are
node.
name node for storage purpose, and for processing, okay,
Job
we
track.
job tracker, that is resource manager, we say, right? Okay, you say like, okay, job tracker. In bracket, I'm saying resource manager. Currently the name, right? Resource manager. So I'll show you both the architecture, old architecture and new architecture, right? If anyone who is going as experienced, right? You need to have known both previously and now how it's that both architecture I'll be discussing, right? And within the slaves, what are the thing? Data node 1 and task tracker 1. Data node 2, task tracker 2. Data node 3, task tracker 3. This is what, so group of, see this entire thing, right? Group of nodes connected in a network, we call this as a cluster. Group of systems interconnected, master nodes, slave nodes. So there will be 2 nodes here, 1 master and multiple slaves. See, first, if any file coming to it, f1.txt file. Who handles it? If I need to store it, right? For storing it, who is responsible?
Name node.
First, the request goes to name node. What name, for example, whatever is the file f1.txt, what name node will do? It will divide the file f1.txt, right? It will divide the f1.txt into multiple blocks, depending upon your block size. If you have given block size as 100 or 128 or 150, depending upon that, each one will have that block size, fixed size, equal size. Who does this? Name node. And name node stores them in different slaves. That is, who is responsible, who stores it, and data node will be responsible for storing these blocks. Okay. Now, job tracker, it will be assigning tasks if any processing request has come, okay, this is storage request. Any processing request has come, first the request goes to whom? Any processing related request comes. Storage request comes, it will go to name node. If any processing request comes, to whom it goes, right? Yes.
Job
Job tracker. What job tracker does means, job tracker divides that particular job into tasks. T1 task to task tracker 1, T2 task to task tracker 2, T3 task to task tracker 3. These task trackers are like the slaves. Means like, for example, you brought some slaves for building construction, right? Slaves means laborers. Means you will be dividing the job into tasks and you will provide that task to multiple slaves. Here also same, job tracker divides the job into tasks and assigns that tasks to multiple systems. S1, S2 and S3.
If we want both the store and processing as well, then
See, both storage and first you will store it. Later processing will happen, right? First the file storage and next the processing happens. So file storing, how it happens? First it will go to the name node. Name node divides into blocks. That will be, it will distribute across multiple steps. Next processing means job tracker. It will divide how many blocks. How many blocks means 1, 2, 3 blocks means 3 tasks. T1, T2, T3. 3 tasks. Job tracker assigns the task across the slaves.
if the continuous online streaming is there, then
Okay, for online streaming, right? Hadoop integration with Kafka. Hadoop integration with Flume. We have got separate things. Flume, Kafka. These two are for streaming. They are used for streaming data. They're used for streaming data. What do you mean by streaming data? Streaming data is nothing but data which keeps on generating, which keeps on incrementing.
Live data.
Yes, live data. Data which keeps on incrementing. That data, live data or streaming or incrementing data, right? The data which keeps on incrementing means, for example, this and this you observe, right? Two files, f1.txt file, f1 file, this is f2 file. F1 file is some movie file, some 2 GB file. If you see like morning, it will be 2 GB only. Afternoon, the file size will be 2 GB only. Evening, if we see, like it will be 2 GB only. After 10 days, if you see also, the file will be 2 GB only. This file, this kind of file, okay. But F2 file, some CCTV or webcam, right? Morning, if you see the size was 2 GB. Afternoon, if you see it was like 4 GB. Evening, it was like 8 GB. After 10 days, like 80 GB. Means this keeps on incrementing, keeps on generating. Such kind of data we call like streaming data, right? For this streaming data, to handle this streaming data, we have got technologies like Flume, Kafka, right? So where it keeps on capturing data, right? After capturing and dumping into Hadoop, capture and dump into Hadoop. Generally, from databases, right? From databases to Hadoop, we are using Scoop. Scoop is one data ingestion tool. Flume is one data ingestion. Kafka is one data ingestion tool. Okay. From databases, we use Scoop. And for streaming data, we use this, right? And we'll dump the data into Hadoop.
For
After
batch, it is scoop, right?
what is it?
For batch, we use scoop. For batch data, we
Yes,
use
batch
scoop.
data, scoop, right? Scoop is for interacting, import or exporting data from database to Hadoop and Hadoop. That's why SQOOP from SQL and from Hadoop. So this ESQ is taken from here and this OOP. So this scoop is for only between the interaction between the database and Hadoop only, for no other sources. So interacting between database and Hadoop only, this scoop will work for databases and Hadoop only, but not for any other things, right? Scoop. That's why the full form like SQL plus Hadoop, interaction between them. So Spark, right? Very high speed processing, in memory computation, right? In memory computation. So there won't be anything theoretical, right? Means today and tomorrow I'll be discussing. Tomorrow some other things we need to understand, right? But from the next week onwards, there won't be anything theoretical. Everything whatever I'll show will be practical, right? So in the tomorrow session, just I'll be briefing you about the software, other things, right? So yes, in memory computation we see. Means in Spark, very high speed processing. Means your storage happening within the memory level, within the RAM level, processing happening within the RAM level. Means you are storing in the RAM and processing within the RAM, both happening. That's why in memory computation we see. Means just now you said events generating, live streaming, you are saying live streaming, right? Events are generating at one side and the processing should happen at the other side. So to match the speed of that event generation, event generated means evenly that event should be processed. Event generated, event should be processed. Means that kind of high speed technology required. Means how much fast the streaming is happening, in the same way the processing of that events has to happen in the same speed, rate of speed. So Spark is such a kind of technology, right? So Spark is such a kind of technology which can process that events at that same rate of speed, at the same rate of speed, right? So that's why
Here, Kafka and Flume, Scoop, these are not required, right?
See, for capturing how they are getting captured. So this Flume and Kafka are the technologies, right? Used for capturing the live streaming or streaming data, and they will be dumping into the Hadoop environment. Later, it will be processed by Hadoop or Spark, right? And based on the business logic provided, right? So for processing them, right? We require a very fast technology like Spark. So here for streaming, right? Spark has got the concept of micro batching. Hadoop is for batch. Batch means, okay, micro batching means for every 5 seconds I want updates. For every 10 seconds I want updates. Means batch means what? Total 1 month data or last 1 year data. Means Hadoop generally huge data from different sources, from 50 branches. I'm bringing the last 1 year data and I want to analyze it. I want to process it, some business logic. That is what batch processing. Micro batching means small micro batches. I need to process immediately. I need to give the results. I need to showcase the results, right? Fine. So okay, so for this, I'm going to provide knowledge on the streaming. So I'll be providing knowledge on two streaming technologies like Flume, Kafka. Right, this is, and I'll be giving knowledge on one NoSQL database, HBase, and one data warehouse kind of environment like Hive. Only on Hive you have got a lot of jobs. You got knowledge in Hive and Hive SQL, right? And Spark with Python implementation. Spark with Python implementation means Spark is an execution model which is implemented by using a language like Python. Python is a simple language, right? It's very less coding. Yes. Fine. So hope you understood this entire Hadoop architectural, right? And what is stored in the master level, what are stored at the slave level, in the master name node and job tracker, and in the slaves data node and task trackers. For storage related, name node and data node interactions. For processing, job tracker and task trackers interactions. And most of you ask a query, if multiple slaves are there, if one slave is down, we have got other. If this slave is down, the work of this slave will be done by either this or this. But if the master is down, it is going with secondary name node. But in the latest Hadoop version, whenever name node 1 is down, we have got name node 2, name node 3, multiple name nodes possible. When name node 1 is down, name node 2 becomes active. If this is also down, name node 2 also, then this becomes active. Multiple name node concept is there, right? Fine. So, okay, next week onwards, right, I'll be spending time with the practicals. So, step by step, I'll be explaining all the things. Tomorrow, I'll be briefing you about the software, other things. So, before I go with the actual practical part in the next week, right? So, I'll be briefing with the basic Linux commands. So, total basic commands knowledge is required, not the entire things. Basic Linux commands knowledge. Need to have the knowledge about the basic line. I will be briefing you about the basic Linux commands before I go with the practical part, right? So some more small things you need to know about, and tomorrow I'll be briefing you about those things before I go with the practical. There's nothing theoretical here, everything practical, right? So I'll be showing you everything practically, right? So any other queries, right? Any queries? Yes. So I'll stop.
So can we see you like it's difficult to like without seeing you.
So no. This is so I want the sessions to be more interactive that you'll be seeing in the practical sessions, right? So you'll be interacting with me every line I type, every practical statement I type. I'll be asking you what will be the expected results means, what results you are going to get, what output you are going to get for every statement I type, right? You'll be responding, right? Means as a you need to know, right? As a data engineer, right? You need to know if I apply any command or if any API I'm applying, right? You need to know what output I'm going to get in before, right? So there are many inbuilt APIs available, right? So it's not like me speaking and going off. I want the interaction from your side. Total, if you're taking 2 hours or 2.5 hours, right? I want you people to interact with me. That's why through short panel or through voice, right? I'm expecting that if I want to deliver the subject more effectively, I want more interaction from you. Okay? See, we'll be discussing a lot of things. That's why it's a 12 weeks, right? It's like a 12 weekend batch, like 3 months it takes, right? So that in brief, in depth, we'll be discussing, right? It's not like overview. We'll be discussing everything in lot of discussion on Hive, right? In Hadoop, I'll be concentrating more on Hive, next on Scoop in Hadoop. In Spark core programming and Spark SQL programming, right? Yes, data frames.
So we are going to cover like PySpark completely, right?
Yes, so PySpark, you can see that in brief, in depth. See that if you see that syllabus of this PySpark.
Okay.
So here, starting from this RTD computations, persistence, memory level, PySpark core computations, groupings, aggregations. We have got many inbuilt functionalities available. We don't need to write huge codings, right?
Yeah.
Like if you want like count by key, count by value, sort by key, zip, union, distinct. We have got many functions available. We don't need to write code for Cartesians, co-group, and for SQL data frames, right? In making the data structured in rows and columns. And even we can make use of this pandas data frames also, right? Pandas concept also, we can just take the advantage of it right from Python. And if you see here, making data structured, creating RTDs, many inbuilt functions like select, collect with column, where, drop, order by, group by, union, UDF, flat map for each sample, sample by, fill nulls wherever required, right? Apart from this, we have got many SQL functions available within this PySpark, aggregate, window functions, date and times templated JSON functions, right? And many PySpark inbuilt functions, like these are all that functions where we can perform different operations. We don't need to write codings, right? So these are all that with many working examples I'll be discussing. Apart from that, from external sources, working with pure SQL statements or with Hive integration, Spark and Hive, Spark and MySQL, working with CSV files, JSON files, narrow and wide transformations, adding columns, removing, handling nulls, joins, writing data to external sources, deployment modes, PySpark applications, stages, tasks, diverse executors, building Spark applications, deploying performance tuning with streaming concepts, integration with Kafka, and also knowledge on machine learning, ML also I'll be providing, right? And only thing is being regular to the sessions and trying to interact with the sessions, right? So whenever I will be, and depending upon, sometimes I'll be taking some bigger sessions, right? I'll be pre-intimating you if everyone are fine with the timing, right? So when we are going with the more examples, more working examples, we need to spend some time, right? Fine. So up in the Hive also, if you see, I'm be spending a lot of, see, this is the entire thing, Hive built-in functions, how to load files, internal, external tables, Hive working with unstructured, with XML data, JSON data, URL, weblog data, inserting UDF, UDFs, partition, non-partition tables, dynamic partitioning, performance tuning, bucketing, indexing. So this Hive also in brief, in depth. Only if you got good knowledge at Hive, also only on Hive you have got jobs. Yes. Okay, fine. So tomorrow the session starts at 6 p.m. Right? So you can join the session, right? But try to get, you can see in the chart still, if anyone, right? If you're not enrolled, right, you get enrolled. See the payment details, procedures, everything is given here. The course content is given, demo video is given, the details, contact details of this online team is given, right? The payment procedures, everything, right? So complete everything, right? So for forwarding the softwares, for notes, for the notes to be forwarded, for the software to be forwarded, and for adding you in that WhatsApp group will be there for technical discussion. So whatever I discussed, right, everything clear notes. So here batch applications. So if you see clear notes, I'll be providing for all the topics, right? If you talk about Hadoop.
So will you discuss about creating data pipelines?
Here it's a data flow language only, right? Data pipelines, everything we deal with data pipelines. So here, this is the PySpark notes, step by step, all the notes I'll be forwarding you topic wise in notepad format. Okay. calculating the cluster memory, PySpark data and timestamp functions, PySpark streaming, Kafka nodes, PySpark machine learning nodes, right? And coming to this Hadoop also, right? In brief, in depth, we'll be discussing, right? Hadoop, if we talk about this Hive, part 1, part 2, Hive nodes. Okay, so
So
don't
this
worry
is
about the
also
nodes.
this is also called data engineering, right, sir? So when you say analytics,
What is it?
so
Yes,
it's
yes, yes,
okay.
yes. So okay, that's fine. So get enrolled, right? See that payment details, other things you can see in that chart panel. You can copy that if you're not enrolled with that. For getting the videos, you'll be getting to your Google Drives. Notes you will be getting to your mail IDs. WhatsApp group you will be added. Yes, fine. Softwares also you'll be getting to your Google Drive, right? I'll be demonstrating about it. So next week onwards, we'll be starting with the practical part. Tomorrow I'll be just some left out things I'll be discussing, right? Means or before we go with the practical part. So okay.
How
So
long we can use it?
here, how long you can access the
Video?
videos? Videos access will be six months from now. And
Okay.
later, if you want to extend also, you need to talk with the office team, right? And if you want, you can discuss with them, right? Fine, but six months it will be from here on, right? You can access the videos. Fine. So I'm stopping for now. We'll continue tomorrow, 6 p.m. right? Yes. Fine. You can follow this link, same link, to see more discussion on this, right? So